For our EEE174 final project, we did a temperature sensor display with an LCD and an indicator LED. I'm Veronica Holt, and I will be presenting the first couple slides. So for a project overview, we used an STM32 board and connected it to two temperature sensors, temp sensor A and temp sensor B. We also used connected an LCD to our STM32 board, as well as a resistor and red LED that would blink if the temperature values from A or the temperature values from B varied by more than 3 degrees Fahrenheit from the other temperature sensor value. And then finally, we did have a Raspberry Pi connected as well, and that would save the data of both sensors onto a TXT file. Now, my part of the project was configuring the temperature sensors, and so I worked with temperature sensor A and B. I connected both to the ground pin and the 5-volt pin. And the GPIO output pins A1 was connected to temp sensor A, and A0 was connected to temp sensor B. And so these temperature sensors, they're specifically DHT11 sensors. They record both the temperature and the humidity data, but for this project we just needed the temperature data, and we were able to see the temperature data using the debugger under the live expression tab. And so for temperature sensor A, the temperature variable that I use for that is temp1, and for temperature sensor B I use temp2. So that's the naming conventions. Now, as far as going through the tests, I initially ran a source code. It would just basically read one DHT11 sensor's temperature and humidity data, and for temperature sensor A it worked perfectly fine, but temperature sensor B it did not work at all. And so after running the main code where we detected both sensors, after a lot of hours of troubleshooting it, my group came to the conclusion that temperature sensor B has some sort of internal error and did not display any temperature values. And if you look at the screenshot of the debugger, temp1 and the temperature1 variable is temp sensor A, and that is about 77 degrees. So that makes sense, but temperature 2 and temp2, the variable, they're the same. They read 0. So unfortunately, temperature sensor B did not work.
Alright, and for my role, I needed to configure the DHT11 temperature sensors to the STM32. And the goal of this was to establish connection between the two, allowing them to communicate smoothly, as well as signal to the LED based on the temperature readings. In addition, it needed to fit in with the other pieces of code and other pieces of the project, allowing everything to smoothly send the signals as needed regarding the readings and receiving the information regarding the readings, and just work cohesively as a whole. And unfortunately, there were some struggles to make it connect as one. Some of the reads were a bit inaccurate. Some took a little bit too long, which there are various variables for that, but you know, I think some of that has to do with the configuration as well. And right here is the main core of the code that I came up with, along with the pin setup I used to do the individual piece of the project. That was just from what I did on the side, with the GPIO output for the LED and the input for the temperature sensor, as well as on the left just with the code, seeing the GPIO pins and setup, as well as configuring the clock, and that's the main core of it, yeah.
So here is basically what a demo of what our LCD should look like with temperature 1, temperature 2, and the difference. However, as of right now, we only have temperature 1 working. This is just with temperature 0 plugged into the code, not with the actual sensors working with it, just 0. So here, for the LCD, it has 4 pins: the ground, the 5 volt, and the SCL and SDA. Our microcontroller only has 1 pin for the SCL and 1 pin for the SDA, so it has to be connected to D5 and D4. So the LCD wasn't too difficult. There was a good amount of issues. Some of them were the right format. As you can see, the LCD has only 2 rows. So if we try to display it like a lot more than that, like the actual word temperature, it would basically just cut off, and yeah, it wouldn't fit on one of the rows. Some of the other issues we had was the LCD only displaying one temperature while everything else was just flashing a whole bunch of symbols. And yeah, we also had it where it didn't even work, and it would just flash a whole bunch of symbols or not display anything. So we had to adjust our code for that. Here's our code for the LCD. Clearing it first is really important. It helps us so that when we run the code, some of the old information from the last run doesn't stay on there. Sometimes it does break the LCD when we try to run it and when there's already data on it. This part just initiates it. So here we display the temperature of the first temperature sensor. A lot of it is just a repeat. So what we do for temperature 1 is we do for pretty much the same thing for temperature 2 and the difference. So here we just create an array. This is like the cursor of the LCD saying it will start in the first row, 0 column. So here is just the format, and then this will send the data to the LCD with the units or with the numbers. The delay is also really important, otherwise it'll send the information way too fast and sort of break the LCD. And this is just the units of Fahrenheit. So we basically do the same exact thing with temperature sensor 2, but we use the data from the second temperature sensor. Yeah, the same thing with the difference. Just we subtract the temperature from one from the other. And yeah, that's all for.
So up next we have the data logging, which for this project we chose to use the Raspberry Pi 4 Model B. What this device is it's basically a compact computer that could run Linux and contains its own GPIO pins. The way we set it up is you download an operating system onto a micro SD card, which then gets inserted into the Raspberry Pi. So the device is usually connected up to its own monitor, mouse, and keyboard setup, but we were able to configure it to run on our laptop using a VNC viewer and a Wi-Fi connection. And what makes this device so special is that it's essentially its own computer with built-in GPIO pins, which makes it easier to log data and you don't have to go back and forth between devices. To log data using the Raspberry Pi, I found it easier to use Python. So what I did is I wrote and ran a Python program to write data from our inputs every half second onto a CSV file. I was even able to include accurate timestamps for each reading, which included the date and time of day. So to the left here, we have my data logging program on the Raspberry Pi terminal. And to the right, we have the resulting CSV file. This is, however, where we encountered a major problem. We were unable to configure the Raspberry Pi to the school network. And what this meant was that we couldn't even attempt to run the data logging program with the sensors connected, because I couldn't even log onto the Raspberry Pi without a Wi-Fi connection. So to summarize our project, we were able to get each part to work properly, but we were unable to integrate them together. We had a faulty temperature sensor, which meant that if our working sensor was giving us inaccurate readings, We didn't even have a second sensor to double check it. Another problem we had was with the Raspberry Pi. Because we were unable to configure it to the SAC state network, we couldn't even attempt to log the data from the sensor. This has been Veronica, Manav, Jesse, and Uriel, and thank you for watching our presentation.